We're going to look now at limits graphically. So for the function f of x equals y, find the following values. Well, notice that they all approach -2. So let's go ahead and take a look at -2. And we're going to pick a color here that we can see on our graph. So -2 happens to be in this area. So I'm just putting a dashed line there on -2. So in the first case, we're approaching -2 from the left-hand side. So coming in this way. So we look at our function, and it's coming in, and it seems to be approaching this value right here at -3. So there is a hole there, but we do get very close to -3. So we're going to go ahead and state that when x approaches -2 from the left-hand side, we are very close to -3. Now, let's take a look at the other case that they ask right there. And that is that the limit as x approaches -2 from the right of f of x. So we're coming in from the right, and we get very close to this value right here at 6. So although again there is a hole, we are approaching the value of 6. So we're going to write 6 there. Now the question, the third part of this states, well then what is the limit as x approaches -2 of the function f of x equal? Well, guess what? This does not exist. Now it's very important to remember the fact that the limits here must be equal when you're approaching from the left and from the right of the same value. So these two are not equal. Therefore, the limit in general does not exist. Now, we're going to check to see what f of -2 evaluates to. Well, that's pretty easy. All we have to do is look at the graph here, and we see very easily that it equals 2. So f of -2 simply equals 2. So we've answered all of the questions for this example. And we took a look at limits graphically. So once again, the important takeaway from this is that the left-hand side and right-hand side limit must be the same in order for the limit to exist in general.
Made with Doodlecast Pro.